So in this video, we're going to be learning how to perform web search in LangChain, how to perform web search in your LangChain applications. Now, as we all know, let's get to our whiteboard. As we all know, LLMs have a cutoff date with their training. So when an LLM is being trained, let's say this is an LLM, let's take it as a brain, and the LLM is GPT-4, it can have a cutoff date of, let's say, October 5, 2024. October 5, 2024. Now, what this means is that any information, any piece of information that came out after this date is not going to be available to this LLM. It's not going to be available, and most especially the public one, because most of these LLMs are trained on basically the web. So if something comes out, let's say a particular team won a World Cup in 2025, even though next year is the World Cup. So let's say the Champions League. PSG currently won the Champions League. So if you ask GPT-4, whose cutoff date for training was October 5, 2004, if you ask it about the winner of the Champions League in 2025, which is PSG, it won't be able to answer you. It won't be able to answer you. And the fact that you mentioned 2025, it will recognize its own cutoff date, and it will tell you, yeah, I can't, as of my cutoff date, I can't provide this information. But this has when these LLMs first came out, this was a major limitation, and people just kind of lived with it. But now, with tool calling, with function calling, LLMs are now able to browse the web. LLMs are now able to browse the World Wide Web. Yeah, LLMs can now go on the internet and go and look for recent information. So even though the cutoff date of the LLM is probably sometime around 2024, if you ask it about the 2025 fact, it will prompt you, some of them will prompt you that they will need to search, and then you will say, okay, yeah, go ahead and search. I think that was around when the whole browsing feature first came out. But now I think they just do it under the hood. Gemini will do it under the hood, Claude will do it under the hood, and they will just go to the internet and just go and search relevant information. And sometimes you can even directly dump a URL into the chatbot, and it will go and search. So today we're going to see how we can build this feature into our LangChain applications, how our LangChain application can get a query and determine if it needs to search the web to handle the query. So that's what we're going to be doing. Now, like I mentioned, this is going to be done through tool calling. So we need to give our LLM a tool. We need to give our LLM a tool, and that will be a browse tool. A browse tool, or you can call it a web search tool. A browse tool. Now, LangChain supports a couple of them. There's Sapper.dev, which is one of the very popular ones. Also very popular with CrewAI. We're familiar with CrewAI. CrewAI kind of uses Sapper.dev like a default. There's also Google search. You can use the direct Google search, grounding with Google. You can use Bing search. But today we're going to be using Tavily. We're going to be using a service called Tavily to perform our website. So we're going to be using the Tavily search tool to perform our web search. And why Tavily? Mostly because if you check the integrations page of LangChain, Tavily is free, or at least it has a very generous free tier. If you're going to use Google or the rest, they're paid. And we don't want that to be a blocker for you to follow along with this demo. So we're going to use Tavily because it's free. And also, Tavily will return the content of the web page and the answer. It will return the answer for the query, and it will return the content of the web page. Google will return a snippet. Bing will return a snippet. I think probably proprietary stuff. They're just trying to be careful with their information. But Tavily is just going to give you everything. So we're going to be using Tavily. And yeah, that's what we're going to be using to perform our web search in our LangChain application. So now that we understand what this is all about, let's head into VS Code and start writing some code. Just before writing our code, we need to get our API key for the Tavily API. Like I said, we're going to be using the Tavily search tool. So we need to get an API key that will help us authenticate with this Tavily API so that we can use their search features. So just head over to Tavily.com. And this is a tool built specifically to work with LLMs. It's built specifically to work with LLMs. So everything about it is native to how your LLMs are going to operate. So you go to Tavily.com, you log in or sign up with your email, you open a new account, And once you're in, you'll be taken to a dashboard like this. I am still on the free plan too, so almost everything is going to look the same. And as you can see, I have 1,000 credits. I have 1,000 credits. I think they give you 1,000 per month. I don't know whether they still do it monthly or they just give you 1,000 in your free plan. But I have 1,000 right now. I've used 10 out of it. And on this page, you'll be able to see your API key. So you can just click to copy the API key, as I've already done. And now you can have the API key that we're going to use in our project. So do this. This is very, very important because you need to be able to authenticate with the Tavily API. So make sure you get your key and then we can begin to code. So let's head over to VS Code. And I've created a new project folder. Called Web Search. And the first thing we're going to do is to create a virtual environment. Let's create our virtual environment. So I'm just going to pull up VS Code's command palette and just look for the Python command to create a new virtual environment. This comes from my Python plugin for VS Code. If you don't have it, or you're not using VS Code, you might have to create your virtual environment from scratch. So, and once you create it, you make sure that you activate your virtual environment. For example, my virtual environment has now been created. You'll see the .venv. And now if I pull up my command line, you see I'm in .venv. So that's good. That's fine. We can take that off for now. Now, the next thing we're going to do is to install our dependencies. We're going to install our dependencies. Now, of course, you know the usual suspect. We need to install LangChain. We need to install LangChain core. And we're also going to be using OpenAI. You can use any other chat model. You can use Gemini. You can use Claude. You can use Grok. But we're going to be using OpenAI. It's most likely what it's like the default we stick to. We've been sticking to with these tutorials. But one of these days, we're going to use another model, but we're still going to be using the OpenAI. So we're going to install LangChain OpenAI. And also, we'll need LangChain Tavily. Yeah, LangChain Tavily. So Tavily has its own LangChain package, and we need to install that too. So we're going to be installing this libraries into our project. So just going to say pip install LangChain core, LangChain. Then let's install LangChain Tavily. That is LangChain-Tavily. So LangChain Tavily. And finally, we need to install LangChain OpenAI. So we get these four: LangChain core, LangChain, LangChain Tavily, and LangChain OpenAI. And let's hit enter. That should start installing. Just going to wait for the install. These installs don't really take long. So while it's going on, I'm just going to create a file that we're going to be writing our application. So I'm going to create a new file for this project. I'm just going to call it Web Search with LangChain. Web Search with LangChain.py. Create our Python file. And just as I said before we're done creating the file, we already have the installation done. So I'm just going to clear this. By the time you check your lib folder, you should see them here. LangChain Tavily. So that's cool. LangChain OpenAI, LangChain core. So we have those installed. This is, let me escape out of Copilot. So the first thing we're going to do is to bring in our dependencies. But just before we do that, let's make sure that we have the system dependencies first. Before the code dependencies, let's have the system dependencies first. And when I say system dependencies, I'm talking about environment variables. The environment variables that need to be available for this project to run. And we're going to need to set up two of them. The first one is going to be our OpenAI key. For that, we need to say export OpenAI API key. And we set that to the value of our OpenAI API key. That's for the OpenAI API key. That's if you're using OpenAI as your chat model. If you're using Gemini, you have to set the Gemini key. If you're using Claude, you have to use, because we're using OpenAI, we set the OpenAI key. Now, for Tavily, the environment variable you need to set is called Tavily underscore API underscore key. Tavily underscore API underscore key. These are the environment variables that you need to set. So the one for OpenAI, which is going to help us authenticate with our chat model with the OpenAI API, and also the Tavily API key that's going to help us to authenticate with the Tavily service. So those are the two we're going to set. I'm going to be setting it behind camera, so I'm going to be back in a flash. So we're back, and I've already set the two environment variables that are required for this project: the OpenAI API environment variable and the Tavily key environment variable. Now we can start writing some code. Now the first thing we're going to do, we're going to bring in all our required modules. So, but first let me describe the example that we're going to be running. So we're going to create a simple agent. We're going to create a simple agent so that we don't get to start writing complex runnables and start branching them, whether we want to browse or not. We're just going to use an agent straight. And I'm going to be using an agent from the default LangChain agent. Like, that's the native LangChain agent. I'm not going to be using LangGraph. Even though LangChain is really trying to move off from LangChain agents to LangGraph right now, I'm still going to be using LangChain agent here because this is a LangChain series. This is LangChain series. When we start our LangGraph series, which by the time some of you are probably watching this video, that will already be up, and we're doing web search in LangGraph, we're going to see the LangGraph example. But here we're still going to stick to LangChain purely because this is a LangChain series. So we're going to be creating a tool calling agent with LangChain, and we're going to be setting up our Tavily search, and we're going to give this agent our tool, which is the Tavily search. We're also going to give it the OpenAI model, which is the chat model that it's going to work with, and then we're going to use our AgentExecutor to run the agent. We're going to use it to run the agent, and we'll be able to query that runtime and get results that will help us browse the web if necessary, and just use the LLM knowledge base if we don't need to browse the web. So that's how our example is going to look like. So first, let us get in our dependencies. I'm first going to get out get a chat prompt template that we're going to need to set up the prompt for our agent. So from LangChain core prompts, we get chat prompt template. The next thing we're going to do is get our chat model from LangChain OpenAI. So import chat OpenAI. Then we're going to also bring in Tavily search. So from LangChain Tavily, import Tavily search. Yeah, Tavily search. I spelled that correctly. So Tavily search. Then the last thing we're going to do is that from LangChain itself, agents, we're going to import two things. First, we're going to import our create tool calling agent. We're going to import our create tool calling agent function, and also our AgentExecutor, which will be the runtime for our agent. So we have these dependencies in our chat prompt template, which we're going to use to design the prompt that our agent is going to use, LangChain OpenAI for our chat model, Tavily, and our agent imports. So we have those four in. The next thing we're going to do is quickly set up our model. So say chat OpenAI. Set the model argument, and we're going to tell it to use GPT-4. Okay. So GPT-4 or 4o. Let's use 4o. So GPT-4o. So that's our model. That's the first thing our search is going to need. Or rather, that's the first thing our agent is going to need. But our agent is also going to need tools. It's also going to need tools because it's a tool calling agent. So let's set up our Tavily tool. So I'm just going to say search tool equals Tavily search. Tavily search. Search tool equals Tavily search. And this is basically all you need. You can use this tool like this. Search tool is called Tavily search. This constructor has a lot of instance variables, instance arguments that you can set. But the default works fine. But some of the stuff you can set is something like max results. You can set max results. That's the total number of results that you want back. I think the default is 5. You can also set things like the topic, whether it's a general topic or it's a finance topic or it's news and stuff like that. Google search has its categories for searches like that. So you can set that. You can tell it to include images. You can tell it to even include the description of your images. You can tell it to include domains. You can even give it time. You can give it a range. You can give it a range that, okay, probably search from 2000 2013 to 2016. You can give it a range. But for now, we'll just stick with the default. The default works fine. But this is just to make you know that you can go that granular. You can go that granular to make it, to fine tune it more to your use case. So we have our search tool, and I'm just going to set that into a tools list because we need to pass our tools to our agent as a list because we can have more than one tool. So once we have that in place, the final thing we'll need to create that our agent is going to require is our prompt. It's a prompt that the agent is going to make use of. Now we're going to be creating a chat prompt template. That's why we brought it in. We're going to be creating a chat prompt template, and it's going to consist of a series of messages. We're going to have a system message, and the system message is going to be one of the most important message as your query, and it's going to tell the model that if necessary, it should use the web tool. It's going to make the model understand that it has been given a web search tool, and if necessary, it should use the web tool. So we're going to use a system instruction to pass that information to the model. The next thing we're going to have is a placeholder message where we can use for chat history. In case we need more context, we can just bundle some chat history into that, and our agent will be able to use it for context. We're also going to have our typical human or user message, which is where our query is going to fill in. And lastly, we're going to have another placeholder message, which we'll call scratchpad message, a scratchpad, just for the agent to just gather his thoughts and all his reasoning and planning processes. So those are the messages that we're going to have in that order. So we have system message, placeholder message for the chat history. Then we're going to have the user message, which is the main query. Then we're going to have the scratchpad message following that. So let's get that constructed. I'm just going to come down here and say prompt equal chat prompt template. Then we'll call the from messages method. And in here, we're going to pass our list of messages, starting with our system message. So we'll say system message, and we're going to be passing a system message that is going to be quite elaborate. So I'm going to use the multi-string, and let's leave this here. Okay, so system message. Let's put this on another line. Let's put them, I think it will be better this way. Okay, so put this here, and let's put this here. Let me drop this, so that we can have more space. So system message. Now we can write our system message. So this system message is going to say, you are a helpful AI assistant. You have access to a web search tool to get up-to-date information. So use it when necessary. Use it when necessary to answer the user's questions. So use it when necessary to answer the user's questions. So that's our system message. Like I said, we use our system message to instruct the model to make it understand that it has a web search tool. So don't hallucinate, don't try to be a hero. You have a web search tool, you can make use of the web search tool to get extra information or up-to-date information from the web. So that's our system message. Next is going to be our placeholder message, which we're going to use to define our chat history. So I'm just going to placeholder. And this is just going to take a chat history variable. So that's cool. The next message is going to be the input itself. That's the human input. So you can call it user or human. And here we're just going to say input. The variable will be input. And finally, like I said, we are going to have another placeholder message. That the agent can use as a scratchpad. So we're just going to say agent scratchpad. Okay, that's good. just scratch pad. Like I said, the agent's thoughts, reasoning, and stuff can just be dumped there. So, chat history, input, scratch pad, and our main message that instructs the model, the system message. It says you're a helpful AI assistant. You have access to a website tool to get up-to-date information. Use it when necessary to answer the user's questions. So we have the prompts, and we now have everything our agent needs. We have the model, we have the tools, and we have the prompt. So now we can create our agent and run it with our executor. So to create the agent, we're going to come down here, and I'm just going to be lazy and simply call it agent. So agent equal create to calling agent. Yes. And the first thing we're going to pass to it is the model. Next, we're going to pass the tools, and we'll pass the prompt. Pass the prompt. So we give it the model, we give it the tools, and then we give it prompt. But we need to run the model. We need to run the model. Or rather, we need to run the agent. We need to run the agent. So the agent is going to take care of all the smart decision making, knowing whether it is to use its knowledge base, the knowledge base of the model, or to go to the web to search. But we also need to put it in a runtime and run it. And the runtime is going to make sure that error handling and iterations over different results until the final result is produced is done, and all those kind of reliability requirements for our agents to run. So we're going to say agent executor, and we're going to call the agent executor constructor and pass it our agent. So agent, we set it to agent. We also pass it our tools. And I'm going to set verbose to true because I want to see all the lovely behind the scenes activities. So set verbose to true so that we can see all the details. Like I said, the agent or executor is going to be responsible for running the agent. He's going to manage the tools, and he's going to iterate over results until we find one that is suitable. So now we have our agent and our agent runtime. Everything we need to run our demo and see how web search works in LangChain. Now we're going to be running 3 demos. The first 2 would require web search. So we'll see how the agent does web search, or figures out that it needs to search the web and does the web search. Then we're going to throw in a third example, a control example that would not require web search, and we'll see what the agent does in that case. So let's begin. Example 1, I'm going to add a print statement here just to make our outputs lovely. We'll say invoking the agent executor. So invoking the agent executor. Now we're going to run our first example. We're going to call that response 1, and that will be agent executor dot invoke. Our agent executor is also runnable, so yeah, invoke works. And we're just going to pass in our input. We're going to pass in our input. Passing our input, let me make this multi-line. So we say input. Yeah, so input. And we're going to ask it, what is the latest Python version? Now, this is something that it needs to be up to date with. What's the latest Python version? I'm also going to set the chat history input variable. We're just going to set that to an empty list for now, so we don't have any chat history. But if you have previous contextual information you want to feed in, or just want to dump the chat history for the agent to inherit from, and also use it as context for the next query, definitely this is where you stick it in. So we call it with this input, and we ask for the latest version of Python. And let us print out the response. So I'm going to say print f-string. Let's have a new line there. I'm going to say user query 1, which is what is the latest version of Python. Latest Python version. What's the latest Python version? So that is what we queried, and we're going to print our response. So what did our agent say? Agent response 1 is, sorry, yeah. So That'll be response 1. Response 1, and we get the output of response 1. Get the output of response 1. Then just to demarcate it from the next example that we're going to be writing, let us print some, characters under there. So I'm going to add a new line, and I'm going to add 50 equal signs. Yeah. Okay, new line, let's have this here. So I'm going to add 50 equal signs. Just going to multiply that by 50. Then we add another new line character here. Okay. So that's good. Now we can run our first example. Yeah, these examples, I like them to look beautiful. So you may not need a lot of all this print statement there, but this is a tutorial, so we need to make things look pretty. So yeah, response. Let's go back to how everything was done. So we got our dependencies in. We set up our chat model. We set up our search tool. We created a list of tools. Then we built our prompt specifically for the agent. We passed these 3 elements, the model setup, the tools, and the prompt, into our agent using the create tool calling agent. We use our AgentExecutor as a runtime for our agent. And now we are doing the first run of our agent. We're running it, and we're asking it what the latest version of Python is, which is a query that would require web search. Now, let me pull this up. Also remember that your API keys should be set. So if you've forgotten that or you skip that, make sure your API keys are set for OpenAI and for Tavily. Let me pull this up a little bit, and we're going to run our file. Now, before we do that, sometimes it goes to the web and it just tells you you found nothing. So that might happen in this case, it might happen in some runs, but let's just check it out. Let me stop talking. So web search with LangChain, the PY, let me pull this up more because we're going to be seeing a bunch of the behind the scenes. Let's hit enter. Enter. Waiting for it to run. See, it starts, it enters the AgentExecutor chain, is invoking a web search with Tavily right now. You can see the query, and it's done. So let's look at it from the top. So it invoked the web search with Tavily using it just said latest Python version. So it went into our query, our user query, and just extracted the most important parts that needs to go to the web. So latest Python version. So it queried that, and I got some results, Python Insider, something from Python Insider, so blog.python.org. And I think it was able to figure out that Python 3.13 is the latest. Anyway, let's go down. So after all that raw web search comes in, the agent is going to clean it up, and then we can now see the chain is finished. And here we have user query 1. What is the latest Python version? And the agent response is the latest Python version is 3.13.5, which is the 5th maintenance release of Python 3.13. You can read more about it. So it even gives us the reference. So these are some of the things that you can display in your application. Oh yeah, these are the references for this particular result that we're showing you. So awesome, pretty awesome. So everything is working fine. Now we can happily run our next examples. So this is our next example. Let us throw in another search that is going to require, another query that's going to require a web search. So for that, I'm going to come down here. We'll say response 2 equals AgentExecutor dot invoke. Let's have input. We have input. And for this, we're going to ask it what's the current weather, because weather is also a current information. Weather is also a current information. So we can say, what's the current weather in Los Angeles, California? So what's the current weather in Los Angeles, California? Then this also would have a chat history of blank. So it's a chat history. Set it to an empty list. Am I missing out something? Okay, yeah, a comma is missing here. Okay, so chat history is set to blank. And now we can simply print out our response. So say print, say f string. I'm just going to copy everything here because it's basically the same. I want to type all this again and take you guys through the horror of watching me do all that again. So user query, now say user query 2 instead of 1. Then this will be what is the current weather in Los Angeles, California. Change that to this. This will be response 2. This will also be response 2. And we have our delimiter here. So yeah, you don't have to watch me type all that. So now we have our second query, which says what is the current weather in Los Angeles, California, which is also something that needs to be gotten in the instance. So let us pull up our command line once again. Let's clear the screen. Run our agent once again. Let's see what we get. So it's entering the agent executor chain. It does the tabular search for the latest Python version. So we'll just keep that. Then enters the one for the next one. It's done with the Python version. And now we can go for the weather. But let's go back to the Python version first, which is an interesting answer. So now it's telling us 3.13. The 5 is not there anymore based on this search. So these things can be very, very not deterministic, but they're still going to go towards the same direction. So it's still 3.13, but one was more accurate than the other. Then if we look at the web search, it got online to do web searches. It used the weather API, weatherapi.com to check. And when it got back, it tells us that the current weather in Los Angeles has a temperature of 19.4 degrees Celsius, which is 66.9 Fahrenheit. Then we have, I think this is wind speed. Yeah, the wind speed is 8.6 or 5.4 miles per hour, which is 8.6 kilometers per hour. Humidity is around 3%, and visibility is 13 kilometers. So awesome. The web searches are working. But what if we don't need a web search? What if we just give it a query that uses the agent's knowledge, uses the model's knowledge base instead of having to go online and go and do a web search? Let's check that out. So we're going to create a final query, which will say response 3. Response 3 is going to be set to AgentExecutor .invoke. We have our input. And for this, we're going to say, write a poem about brown cats. Write a poem about brown cats. Now, this is something that aligns more with the generative features of the model. So the model will basically generate something new for us. So yeah, brown cats. Yeah, I'm trying to look for a more peculiar example. Let's say robots or something, but no, I think brown cats works. So again, our empty chat history, just to satisfy that requirement. So yeah, give us this. Write a poem about brown cats. Then we're just going to copy this again so that we don't have to type it all over. Then we're just going to copy this all over again so that we don't have to type it all over. Come down here. Now this will be query 3. Query 3 is write a poem about brown cats. So yeah. And agent response 3, response 3. Good. This does not require a web search. Yeah, it should not do it. I'm not sure someone has written a poem about brown cats before, so it should just generate it from the model's knowledge base using the model's generative features. Let's pull up our command line. Let's clear this once again. And now let us run this agent once again. Gets the agent executor. So we do the Python version first. Now it's giving us 3.13.4 or 3.13.4 as the latest version. For the weather, basically the same thing because the weather has not changed since the last query. And now we have the final output. Now, if we go up and see where it started this, you see entering executor chain, you see it didn't perform a web search. Unlike the other ones where if you look at the weather search, it invokes Tavily. It invokes the Tavily search. It didn't do it for the poem. It just generated it. In the heart of a sunlit room, they stray, velvet paws on carpet softly play. And that's what it just gave us here. In the heart of a sunlit room, they stray, velvet paws on carpet softly play, eyes of amber, warm and wise. Just uses the model's generative features. No need to search the web. No need to search the web. How awesome is that? So we have been able to see how our website works in LangChain using a tool calling agent. Smartly decides when we need a web search and when we don't need a web search. And we can see how the agent executor runs it and just gives us beautiful results, up-to-date results for any factual information, and falls back to the generative abilities of the model when we don't require a website.